off the material. We're gonna mostly finish up the material for our first exam. So we're gonna work on predicates and quantifiers for mostly today. Next Monday, whatever we don't finish, we'll spend about a half hour finishing up. We might have to do like some of the multiple quantifiers, and we might have to do a few of the Venn diagram stuff at the end, which won't be too difficult. And then what I'm anticipating is about half the class will spend just talking about what's going to be on the examination. Okay, so generally what I do to review for an examination, I make up the exam ahead of time, and I just let you guys know like the types of questions that'll be on there. Okay, so it shouldn't be a surprise as to what's on there. Sometimes I just cut and paste stuff from the actual practice exam. Sometimes I take problems off the assignments. Okay, but basically the assignments are a good gauge as to what to expect to see on the exam.
Can you give us the answers on Monday?
For the practice exam?
Just say for the exam in general.
To the examination?
Yeah.
I could, but then I'd have to make up another exam. so no, I guess I won't do that. Okay.
I didn't look on Blackboard. Is there still going to be homework too on Wednesday?
Yeah, what I'll do is I'll make the assignment number 3. I guess I'll just make that due I'll probably make it due the day after the examination, the class after that. Because that way you guys don't have to do the homework and study for the exam. That would be kind of cool for me to do. Although it's a good way to study for the exam. Yeah, so. Okay. All right, guys, any other questions I can answer? Sir?
Can I have a packet?
You may, absolutely. Yeah, that would be helpful. That's a good question. So, and then actually, to do me a favor, can you pass that behind you? And then there's 2 in there. Can you pass it behind you to the 2 gentlemen in the back? Well, 3 gentlemen, but 1 half is not a gentleman. Sorry, Don. That's kind of fun. All right, so let's go through and start talking about some of the definitions of what a predicate and quantifier is. And when we talk about a predicate, guys, a predicate is essentially almost like a function that's either true or false when you insert specific values, okay? So when I talk about the definition of a predicate, a predicate is almost like a function, except the output is either true or false. Okay, so whenever you guys are doing this, you don't necessarily get a value out. You don't get a number out of it, or you don't get like anything like that. You just get a true or false. Okay, so the only outputs for a predicate are true and false. Okay, so it's sort of like a function in some respects, but in some respects it's not. Okay, and you guys know that there's only a certain number of values that you can plug into a function. Same thing with the truth set, okay, as a predicate, that is the domain. Okay, so there's going to be sometimes you can't put elements into it. Okay? All right, and then the truth set of a predicate are all the values that make a predicate valid. So I just want to go through and show you a very basic illustration of what a predicate is, okay? And then we're going to start talking about quantifiers. But basically, this whole packet and the rest of the class before the first exam is going to be on what predicates are, okay? So I'm going to have a predicate, okay? And the predicate P of x is going to be x greater than 1 over x, or greater than or equal to, okay? First thing I want to do, I want to write P of a half, P of 1, and determine their truth value. Okay? So if I wanted to write P of 1 or P of 0.5, okay, P of 0.5 is going to be 0.5 greater than or equal to 1 over 0.5. Okay? So that's what our predicate would look like when we substitute the value in. Okay? So like I said, it's just like a function, except it has a symbol on the other side. Usually functions don't have this. Okay? Now, guys, what's the output for this truth, or what is the truth value for this predicate when substituted? It's false, right, guys? Because we know this just works out to be 1/2 is bigger than 2, and that's not true. Okay, so the output is false. Okay, so that would be the truth value for this. Okay, so guys, predicates are very easy to work with, right, guys? They're not difficult. Okay, you stick a number in, it's either true or false. So you got a 50-50 shot of getting it right. You also have a 50-50 shot of getting it wrong. P of 1 is just 1 bigger than or equal to 1 over 1. And guys, what's the truth value of that statement?
True.
To go be true, right? 1 is bigger than or equal to 1. Okay? So we would say this is true. Okay? All right. We wish the entire exam was made up of this question, right, guys? It'd be really easy. Okay? All right. Let's talk about truth sets as well. Okay, we talked about truth values, now our truth sets. So, let's let the domain of the value x be x is a negative real number. Okay, so whenever you guys see r in this class, that's just a real number. Okay, and whenever you see the superscript minus, that's just negative real. So when you guys see this, that's negative real. If I can spell. So it's negative real numbers. Okay. And in the next one, if you see r super plus, that means positive reals. Okay. I want to find the truth set of p of x. Okay. So basically, what I'm trying to figure out is what numbers make that true. Okay. So when is x bigger than or equal to 1 over x true? So that's what we're basically asking. And that's not necessarily an easy question, right guys? Because we know that this is basically going to be a rational inequality, okay? Those aren't too nice, okay? But this is one we can probably just bully and we can try to figure it out, okay? Now remember, we're only dealing with negative real numbers. So what we might want to do is let's just try like some values and see if it's true or not, okay? So let's say for some reason I tried p of negative 2. Okay, so I'm just going to basically do trial and error and see what works. Okay, p at negative 2, negative 2 is bigger than or equal to negative 1/2. Okay, guys, what do we think about that statement?
False.
True or false?
False.
That's false, right, guys? So we know that 2 is not part of the truth set. So what we might want to do is just make a number line. Okay, and all we care about are numbers that are less than 0. And basically, guys, I don't think anything less than negative 2 is going to work, okay? Because think about it, guys, if you plug in negative 3, negative 4, negative 5, negative 6, doesn't that look like it's not going to work, okay? Let's try p at negative 1. Okay. What do you guys think about p at negative 1? Is negative 1 bigger than or equal to negative 1 over 1?
That's true.
That's true, right? So I'm thinking that that's going to be at least part of the truth set. Okay, so maybe what we can do is maybe try a number between negative 1 and 2, and then try a number between 0 and 1. Okay, so let's try p at negative 1.5. Okay, so like I said, we're just bullying this to see if it works. 1.5 bigger than or equal to negative 1 over 1.5.
So 1.5 is 3 halves, right? So
That's correct.
So 2/3?
So
No,
the
false.
That would be false, okay? And you guys could just use your calculator, right? You could see that very easily, okay? So this one doesn't work. So this doesn't work. Right? But I believe 1/2 is going to work if I try to number in between there. Okay, so let's try p at 0.5 negative. And that would be equal to negative 0.5 bigger than or equal to negative 1 over negative 0.5, or sorry, not double negative, double. Okay. And guys, what do we think about that? Is negative 0.5 greater than negative 2? Yeah, absolutely.
True, yep.
Okay. So to me, it looks like that the truth set of this predicate is probably going to be all the numbers between negative 1 and 0. Okay. Guys, does it include negative 1?
Yes.
Yes. Okay, so we would put a bracket at negative 1. Does it include 0?
Mm-hmm.
No.
No, 0, no.
How come it doesn't, guys?
Because infinity.
Because it's not in the domain of the function, right,
Yeah.
guys? Or, I'm sorry, not the function, predicate. Sorry. All I said all my life is functions, functions, functions. This is the one time I get to say predicate. Okay? So, wouldn't the truth set be negative 1, I'm sorry, negative 1 comma 0, negative 1 inclusive, 0 bracket, okay? So when we talk about the truth set of a predicate, we're talking about all the values that make it true, okay? And I know there's a better way to do this, okay? Most of you guys, like some of you guys, if you know the algebraic method, you'd multiply both sides by x, you'd say x squared minus 1 equals 0, you'd find the critical values and then do a number line that way, okay? That's another way to do it, okay? If you don't know that method, just beat it up. Just keep doing trial and error, okay? That's a little bit easier, right? And it's not like I'm asking you guys to do a tough calculator. Okay. Now we're saying, for the last part, let the domain of x be all real numbers. Now we're going to find the truth set of p of x. Okay? So we already know what's happening on the left side of the graph, right guys? So we don't want to redo the whole problem. Now we're just trying to figure out what happens on the right side of the graph, okay? Now think about this, guys. What do we already know about P of 1? Is it true or false?
True.
It's true, right? We already know P of 1 is true. So we know that's going to be, in fact, that's probably going to be the other critical value per se. Don't we already know that 0.5 is false? So wouldn't it assume that anything between 0 and 1 is false as well? Okay? Like if I plugged in a 0.2 or 0.7 or something like that, I know that would be false. So I think the best thing to do is maybe figure out what happens for P of 2. And I think it's going to be very obvious that for P of 2, where 2 is bigger than or equal to 1/2, I don't think anyone in this room doubts it, okay? And if you do, I'm going to beat up your Calc 1 teacher, okay? Well, maybe not, depends on who they are. So if they're bigger than me, no. So if they're smaller than me, yes. All right. But guys, it looks like that 2 is going to work. So doesn't it look like that it's going to be everything to the right of 1, okay? And it's inclusive of 1, right guys? Okay. So if I was to ask you for the truth set for the last part,
1 to infinity.
okay, so it would be bracket 1 to infinity is part of the truth set for this problem, right? What's the other part? Negative 1 to 0, right?
Oh, you.
Because isn't our domain all real numbers this time? Last time it was just negatives. So we're not just specifying ourselves to positive reals. This time it's negative and positive. So the way we would denote that would be bracket negative 1 comma 0 union negative 1 to infinity. Right, guys? Okay. So I'm just trying to give you guys a problem where, like, you see the truth set and you guys can identify the difference between truth value and truth set. Okay? Truth value is either true or false. Okay? A Boolean sort of statement. Okay? Truth set could be an infinite range of values. Okay? So guys, do we understand the difference between it? It's not meant to be different.
I got a question.
Sure.
Shouldn't that be negative 1? Shouldn't that be like one of this, the bracket? Yeah.
Yeah, it is a bracket. Either your vision's bad or my handwriting's bad, or maybe it's both.
Both could
Yeah,
be.
so I'll blame myself on that. Okay. All right, other questions, guys, I can answer about this. Okay, so let's start talking about some of these quantifiers, okay? And quantifiers are going to be the big part of what we talk about in this class from now until the end of the course. We use quantifiers, okay? Right now, guys, I'm just building up your syntax, okay? Just like if you guys were a computer programmer, right? You have some specific syntax that makes the program run. If you don't use the specific syntax, the program doesn't run. Okay. Guys, if you ever see this upside down A, that is the universal statement, okay? Upside down A means for all, for every instance, for each and everything, okay? Any element in the set, okay? That's the ways that we would think about that. Okay? So, if you have a universal statement, okay, and this right here, okay, this is alliterated all x in domain D, predicate q of x. Okay, so this is going to be a structure or a format that we're going to be using quite often today and also quite often in the rest of the course. Okay? This is true if every element in the domain satisfies the predicate. Okay, so that's the only way a for all could be true. Okay, all right. If any one of them's false, that means that the original statement's false. Okay. To verify one of these, to basically counterexample would disprove it, and then you would have to go through something called exhaustion to prove one of these. Okay, so we're going to see plenty of examples of this, by the way, guys. So I know that's a lot to digest, but quite honestly, it's not that difficult. Okay. Because if you think about it, okay, like let's say I said this statement, okay, every student in this class is named Kevin. That's a false statement, right? Because all I would have to do is just point at Paul, and Paul's name is not Kevin, okay? That's a counterexample, okay? But what if I said the statement that every student in this class has taken Algebra 1, okay? Has anyone in this class never taken Algebra 1 or an equivalent of Algebra 1? Don't raise your hand. So let me rephrase that, okay? You might not have passed it, but you took it, okay? Sorry about that, Donnie. I had to get it when I can. okay? But guys, that's a true statement because I've exhausted every possibility. I went around, I looked at you guys, and there was not one instance that said it was true. Okay, so, guys, does that make sense? That's all we're trying to show with this. Okay? The other quantifier is the existential quantifier. Okay? Existential. Look at the word existential. It has the word exist. There exists at least one. There are some. There are a few. Some of these, okay? Those are all different ways to sort of alliterate this guy right here, okay? This is the statement. There exists an element x in domain D such that predicate Q of x is true, okay? All right, it's defined to be true if there's at least one element in the set that makes it true, okay? So all you have to do is just find one person named Kevin, okay? There's a person in this class named Kevin, right? So if I said, there are some students in this class named Kevin, that would be a true statement, right guys? Okay, because there's at least one, okay?
What happened, like, if you said there is every student in this class is named Kevin, everything is false, but there is one student that is Kevin.
Nope, that's not true, not for all.
No,
Okay.
but say, for example, if you say that there's every student in the class is named Kevin, right?
That's a universal statement.
Yeah, but for example, in that way, you know that not all students are named Kevin, but only one, at least one is Kevin, then
Still false.
still false, okay?
Yes, sir. The only way this can be true is if everybody was named Kevin.
Yeah,
So that's a universal. Existential means you only need one, okay? To prove an existential statement true, you just find an example, existence, okay? To prove it false, you have to use exhaustion. You go through, you show everybody's not named Kevin, okay, which isn't true, okay? So guys, that's all these are, okay? We're gonna be using these quite often in class. Let's just go through and take a look at how we're gonna utilize it,
Okay,
okay? It's
it's kinda
actually
like-
very easy to
So
do.
it's kind of like the and the or statement,
What's
and universal is and,
Oh,
everything
no,
is
well, we're gonna see what happens when we put ands in there, okay? Those are gonna be multiple quantifiers, okay? So, but for right now, we're just worried about singulars, okay?
Gotcha.
Alright, so all I wanna do is I just wanna write these symbolically using the